In this video, we're going to talk about basic trig functions. So what is trigonometry? Trigonometry is the study of triangle measurement. There are three basic trig functions. Those trig functions are known as sine, cosine, and tangent. A trig function is a ratio of two parts of a right triangle. So these only work for right triangles. We're going to use that diagram on the left to talk about sine, cosine, and tangent. The sine is going to be the ratio of the side opposite to the angle to the hypotenuse. So if I'm looking at angle A, for instance, the sine of angle A, the side opposite angle A is side A over the hypotenuse, which is always across from the right angle, which is C. Our sine of angle B, the side opposite B is going to be B over the hypotenuse, which is C. So that's sine. Sine deals with the opposite and the hypotenuse. Cosine deals with the adjacent and the hypotenuse. So if I'm looking at angle A, the side adjacent is going to be the side next to angle A. Now, not to be confused with the hypotenuse. The hypotenuse is always the side across from the right angle. We need to make sure we are aware of that. So our cosine of angle A is going to be B over C. Whereas our cosine of angle B, the side adjacent to angle B, is going to be A. So our cosine of angle B is A over C. Now tangent. Tangent is dealing with the opposite and the adjacent legs. So if I'm looking at the tangent of angle A, the side opposite is A over the side adjacent, well, so next to, which is B. The tangent of angle B, side opposite is B over the adjacent, which is A. When people talk about trigonometry, one thing that they always kind of remember is a way to remember those trig functions and those trig ratios and their identities. So we reference something called SOHCAHTOA. So if I'm looking at what I just said, so SOHCAHTOA, what it is it's referencing our trig functions. So sine, so all of these are ratios, right? All of the trig functions are all ratios. And a ratio is a fraction. So if I'm talking about sine, what I'm really talking about is the ratio of my side opposite over my hypotenuse. Cosine is my adjacent side over my hypotenuse, and tangent is my opposite side over my adjacent side. Hence, SOHCAHTOA. So that's just something you want to remember. I would always write it down on all of our notes and all of our homework assignments, so that way we know what we're doing. Let's look at some examples with numbers. So for number 1, I'm given all three sides of my right triangle. That's great. So I don't have to do any extra steps. So now I'm just looking at my ratios. So if I'm looking for the sine of angle A is here. Sine is opposite, which is 5, over my hypotenuse, which is 13. My hypotenuse is always across from my right angle. So it might be helpful to identify which side is your hypotenuse, and it will always be your hypotenuse. It will never be an adjacent side. It will never be an opposite side. It always has to be your hypotenuse. Next, the cosine of angle A. Cosine is the side adjacent, so touching angle A, which would be 12 over my hypotenuse, which is 13. We also want to double check that none of our fractions can be reduced. Next up, the tangent of angle A. Tangent is opposite, which is 5, over the adjacent, which is 12. Still not reducible. That's fine. We can leave it like that. Next, we're going to move on to angle C. Once again, our hypotenuse is still the 13. That doesn't change. If I'm looking at angle C, sine is opposite, which is going to be 12 over my hypotenuse, which is 13. My cosine of angle C, so my adjacent side, is going to be 5 over my hypotenuse, which is 13. And lastly, my tangent is opposite, which is 12, over my adjacent, which is 5. And yes, I would prefer if you leave that in improper fraction. We don't want to change it into a mixed number. Looking at example 2. Example 2, we're missing our hypotenuse. our first thing we need to do is make sure that we can find that, which we can using Pythagorean theorem. So we're going to say that 9 squared plus 12 squared is equal to x squared. 81 plus 144 is equal to x squared, so 225 is equal to x squared. Square root both sides, and x is equal to 15. So this side right here is 15, and that side just happens to be my hypotenuse, because it's directly across from my right angle. So now looking at the sine of angle W, here's angle W. Sine opposite is 12 over my hypotenuse, which we determined was 15. Now looking at that fraction, that is 100% reducible as 4/5. Yes, you always must reduce your fractions. Cosine of angle W. Cosine is adjacent, which is 9 over hypotenuse 15. That reduces to 3/5. And lastly, tangent of angle W. Opposite, which is 12 over adjacent 9. We're going to reduce this improper fraction to 4/3, and we're going to leave it as an improper fraction. Next up, the sine of x, of angle x. X is here. We're using that as what we call our reference angle. From here, the sine is opposite 9 over hypotenuse 15. 9 over 15 we know reduces to 3/5. Cosine is adjacent, so the 12 over 15, which reduces to 4/5. And then lastly, tangent. Opposite side is our 9 over our adjacent, which is 12, which is going to give us 3/4. Bottom line here is make sure that you find your missing sides and you reduce your fractions. Next, we're going to use our trig functions to find missing sides. One key thing to make note of is this right here. We want to make sure that our calculator is in degree mode. If you're using a scientific calculator, more oftentimes than not, your calculator is already in degree mode. If you're using a graphing calculator, we want to make sure that it's in degree mode, and we do that by pushing the mode button, which is directly next to the blue second button. And on the fourth option down, you have two words, radian and degree. You want to make sure that the word degree is highlighted. If it is not, then we won't really get the correct answer. So here's what we're going to do. We're going to rewrite our trig functions so that way we can have them in front of us. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So from here, what we are going to, so the trig functions work for when we don't have a special right triangle. If we don't have a special right triangle, then we have to resort to using trig functions. So what we're going to do is we are going to look at what we are given and what we need to find. So in this question, I'm given the 28 degrees, I'm given my hypotenuse, and I need to find the side opposite the 28 degrees. My trig function that involves opposite and hypotenuse is sine. So I'm going to say that the sine of 28 degrees is equal to my side opposite x over my hypotenuse 19. We treat sine of 28 as a whole number. So as a fraction, it's sine of 28 over 1. That means I can cross multiply. So x is going to equal 19 times the sine of 28, and you can put that directly into your calculator just as you see it, and you would get x equals 8.9 rounded to the nearest tenth when you put it into your calculator. Number 5, our reference angle is right here at 41 degrees. We're looking for the side opposite. We are given the side adjacent. That means I'm using tangent. So the tangent of 41 is going to equal opposite x over adjacent 32. Once again, we cross multiply. X is equal to 32 times the tangent of 41. Putting it into our calculator, we're going to get 27.8 out. Remember, if you're not getting this in your calculator, that means that you might not be in degree mode. So make sure that you go back and make sure your calculator is in degree mode. Number 6, my reference angle is right here at 21 degrees. I'm being given my hypotenuse. I need to find adjacent. That means I'm using cosine. Cosine of 21 is going to equal adjacent, which is x over hypotenuse 26. Once again, we cross multiply. X is equal to 26 times the cosine of 21, which means x is equal to 24.3. Now, what happens if our cross multiplication isn't that nice? Okay, let's take a look at number 8. Here's my reference angle. I'm being given the side opposite, and I need to find the hypotenuse in this case. So once again, our trig functions, if I'm dealing with opposite and hypotenuse, I am using sine. So the sine of 33 degrees is equal to opposite 15 over x. Okay, this is still over 1. We can still cross multiply. This time, I'm going to have x times the sine of 33 is equal to 15. I want just x, so I need to divide both sides by the sine of 33. That's going to leave me with x equals 15 divided by the sine of 33. We can put that directly into our calculator as is as well, and we will get 27.5 out as our answer. So we're still cross multiplying, we're still solving for x. Let's go ahead and take a look at the word problem. So number 12, Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? Let's draw our picture. So we have our house, and we have a ladder leaning up against the house, creating this right angle. Our ladder is 12 feet long, and our angle that it's making with the ground is 68 degrees. I want to find how high up the house he placed the ladder. That's where, the distance from the ladder to the base of the house is right here. It's x. So looking at what we have and what we need to try to find. Here's my reference angle here. I'm being given my hypotenuse, and I need to find my side adjacent. So that means I have to use cosine. So I'm going to say that the cosine of 68 degrees is equal to x over 12. Putting this over 1 and cross multiplying, we're going to have x is equal to 12 times the cosine of 68. Putting that into our calculator, x is going to equal 4.5 feet. The key part to all of trig functions is going to be to look at what you are being given, what you need to find in relation to your reference angle, and then from there determine which trig function that you need to use.